Alright, so I've condensed the reactions, okay, into a few pages, 2 ke 3 pages je. So let's look at our alkene first lah. Okay, apa yang special pasal alkene is that it has a functional group. Kalau apa, alkene before this, it does not have any functional group. Okay, so it has lower reactivity compared to alkene. So since alkene has carbon-carbon double bond, it is very electron rich between these carbons. So it will act as a nucleophile. So your nucleophile, your carbon-carbon double bond, your double bond here yang banyak elektron ni, it will be able to capture any electrophile. Okay, so that means that your alkene, since it acts as a nucleophile, it will always have a type of reaction called electrophilic addition reaction. Okay, so awak tambah electrophile masuk dalam awak punya alkene lah. Okay, alright, so let's look at the first reaction, which is the most simplest reaction. It is hydrogenation. Alright, so hydrogenation, you will require hydrogen, obviously, as your one of your reagents with the presence of your catalyst. So you can use any of these catalysts. Okay, saya letak add tu maksudnya if you are writing your equation, you should just put one of them, platinum, nickel or palladium. Alright, so basically daripada carbon-carbon double bond, you will open up, okay, break one of the bonds and capture your hydrogens. Okay, and then from here, instead of having double bond, you will have single bond. So kat sini awak add your hydrogens lah. Okay, so now your carbon is your molecule is a saturated molecule, have single bonds. So that's hydrogenation, simple je. Next you have halogenation. So there are two ways to perform halogenation. Okay, so this is one way in inert solvent. Okay, X2 is your halide molecule and CH2Cl2 is your inert solvent, dichloromethane. Okay, alright, and here you have another way to halogenate your alkene. Okay, tambah halogen, it is in water. So you will use your halide molecule and in aqueous lah, your water, you have water. Alright, so let's look at the first one here. Okay, the first one right here, when you have your alkene and you are using this reagent, okay, you are halogenating in inert solvent, you will always use this inert solvent and any whether bromine molecule atau chlorine molecule. Okay, so and you will form vicinal dihalides. That means vicinal tu dia sebelah-sebelah, so you will get two halides in your haloalkene. Alright, banding dengan this reaction right here, you will form a halohydrine. Okay, so let's say you have this reaction of your alkene in water. Okay, halogenation of alkene in water, you will have your X minus and you will have your OH minus. Okay, so these two will just attach to your carbon ni lah. Okay, dia akan just attach je X dengan OH, so you will get halohydrine. Okay, so ini in here you will get one halogen in your molecule and one OH as your substituent. Okay, alright, so back to this one, this reaction here, halogenation in inert solvent, it is actually a chemical test yang I pointed out just now. It is called a bromine test. Okay, this bromine test is to test the presence of to find out whether your molecule has carbon-carbon double bond, whether it is alkene or not. Okay, so contohnya, let's say you have an alkene, it is colorless, so you perform the test, okay, this halogenation in inert solvent in the dark, and you will get this product where you have two bromine attached to each of the carbon, one bromine at each carbon. So your observation will be reddish brown color of bromine decolorized. So this one here, before the reaction you have bromine yang color dia reddish brown, and after you don't have anymore. That means that there is a presence of carbon-carbon double bond. So for this one right here, you know that let's say here you have an alkene or any other compounds that does not have a carbon-carbon double bond, so that your observation will be reddish brown color of bromine remain unchanged. That means that your bromine is still in your awak punya system lah. So that means you do not have carbon-carbon double bonds in this molecule. Okay, so that is your bromine test. It's quite simple, straightforward, so make sure to remember lah. Okay, alright, so halogenation in water, you will get halohydrin, I said just now. Okay, so there are two situations. Let's say if you have a symmetrical alkene. Symmetrical alkene maksudnya, let's say if dia symmetry lah, so kalau saya potong macam ni kan, dua ni adalah basically mirror images of each other, dia symmetrical. So let's say if we perform halogenation in water, for this symmetrical alkene, you will attach your Cl and OH at any of your carbon double bond tu lah. Okay, tak kisah letak sini ke OH, letak sini ke Cl. Okay, but if you have unsymmetrical alkenes like right here, okay, if you letak mirror kat sini and awak reflect, dia adalah, if awak potong half, awak reflect, dia tak sama, kat here you have hydrogen and here you have your methyl group. So for this case, okay, how do you know where to put your bromine or OH? Okay, it depends, okay, on this rule here. So the halogen atom will be attached to the carbon with more hydrogen atoms. Okay, so your halogen atom Br2 akan attach to mana yang ada lebih banyak hydrogen. So right here you have hydrogen, right here you only have methyl, tak ada hydrogen. So that means that Br will be added right here. Okay, so now maksudnya OH tu akan pergi dekat sini lah, at this carbon. Alright, so this will be your product. Okay, remember bromine, our halogen, your X will be attached to the carbon with more hydrogen. Alright, okay.